Good evening everyone. Today we are going to do the daily Leetcode challenge of 12 March 2023. That is question number 23. Merge case sorted list. Before moving on with the video, I request you all to please like, share and subscribe. It helps me to make these videos and it motivates me a lot. So now let's move on to the question. The question is saying that we are given k linked list and each linked list is sorted in ascending order. And we have to merge all the linked list. It is similar to the question which is merge two sorted linked list. And if you know that question, you can easily do it. I will explain you both in this question here. So move on to the examples. Let's see if we are given these three linked lists. This, let's say this is L1, this is L2 and this is L3. So initially they will be giving you the head of these linked lists. That is the first point. So what can you do? Suppose there is only two linked lists, that is 1, 4, 5 and 2, 6 is there only. So if we have to merge two linked lists, we will check the first element. If this is L1 linked list and this is, let's say, L2 linked list. We will check if L1 value is less than or greater than this L2 value. If it is less than or equal to L1 value, so as we have to return it in ascending order, L1 is smaller, so we will return our L1 value. That is, we will return L1. So this first pointer is taken. Now we have to merge these things. So if our function is named merge, we will pass what? L1 next. That is next of L1. And we will pass L2 is still at the first position, that is here. And L1 next will become this. So that is how you are going to merge two linked lists. And this is your first condition, if. And if this is not the case, you will apply the else condition. In that you will return your L2. That is, L2 will be returned in this case. And your L2 next will become same thing. This merge function you will apply. What is this merge function? This is your merge function, if and else condition. Also you have to consider the base corner case, that is if L1 is null. L1 is null. If L1 is null, you will return L2. That is, other value is empty. There is no elements here. So that is how you can merge two linked lists. So after merging these two lists, you will get, if you check 1 and 2, 1 is there. Then you compare 4 and 2, then 2 will come. Then you compare 4 and 6, 4 will come. Then you compare 5 and 6, 5 will come. And then finally 6 will come. So this will be your answer if you have to merge two linked lists. Now let's see how can we actually merge three linked lists. So basically you must be thinking, why don't we change it to an array and sort the array and then make another linked list? That can also work, but that will take a time complexity of O of n into k, because there are, let's say, k linked list and you have to apply this operation n times for iterating, and sorting takes n log n as well. So that won't be optimal, and array is also using an extra space of O of n. So we won't be doing this way. So our approach is that we will use this function called merge sort. Have you heard about this algorithm? If not, I will make a video on it, or you can check any other YouTuber video. This is a very famous algorithm for sorting an array. So we will use a similar concept here. We will make a function called partition. We are given a list of vectors according to the question. We are given a vector list. So what we can do, we can divide this into, let's say this is L1, this is L2 and this is L3. So this is your L1, this is your L2 and this is your L3. So you have three linked lists. So what if you divided these two and you applied the merging of two linked list function, and whatever the result is, let's say L4, and then you combine these two. That way you can merge the linked list. Yes or no? So that is what you have to do. So we will make a variable. Let's write 1, 2, 3. Let's say 4 and 5. So there are 5 linked lists in this case. So you will make a variable start. You will make a variable end. So let's mark the indexes. Indexes will be 0, 1, 2, 3 and 4. So what is the mid of 4? That will be second index. So this will be your mid. So now you have the mid element. So what you can do, you can divide, these number indicates linked list. Okay, and there are 5 linked lists in this case, and we have to merge these 5 sorted linked lists. So what we will do, we will divide it into start till mid. That is 1, 2 and 3 values will be here. And we will divide this side into mid plus 1 till end. You will divide this into this. And what is mid plus 1? That is 4 and that is 5 value. Now you can easily merge these two linked lists by applying the function. and here you again have to divide this. That is 0 1 2, you will divide it 2 by 2, that is 1. So this will be your mid. When you have a single linked list left, you will simply return this list as we have seen in the code, that if another list is null, we will simply return this, and this part will be 1 and 2, and we can easily combine these two linked lists by our function merge to linked list. So that is all you had to do in this case. So I hope you understood how can we actually do it. It is a simple question. If you understood it, it is not very hard. You just have to apply different concepts here. You have to know the merging of two linked lists so that you can merge n number of linked lists. That is all you have to do. So this tree length will be around log of k, because you are dividing it into half every time, and you have to do it for n number of lists. So the time complexity will be O of n into log k, and we are not using any extra space, so space complexity will be constant. So if you have any doubt, please mention it in the comment section. I remind you again to please like, share and subscribe. It motivates me a lot. Now let's move on to the coding part. Let's just simply code it. So for coding this, we will write the function first. Let's write the function, that is merge to list. We are writing this function. So in this function, we will provide it with list1 and list2. The best thing about recursion is you can take the leap of faith. If you don't know about leap of faith, check out my other videos of recursion that will tell you about leap of faith. We trust recursion that it can do it if we see a recursive pattern. So what we can do, we will write the base cases first. That is, if L1 is equal to null, we return the second linked list. If L2 is equal to null, we return the first linked list. Okay, and now see, if L1 value is less than or equal to L2 value, what we will do? We will return the smaller value, that is L1, the head of L1. And what will L1 next be? L1 next will be this function, merge to list. We will pass L1 next, and we will pass the L2. And if this is not the case, that means L2 is smaller, so we will return L2, and before that we will change L2 next to L2, this will become L1 and this will be L2 next. So that is all you have to do for the merging two linked list function. After that, what I told you, we have to divide it into partitions. That is, this is L1, L2 and L3. So we need to divide it into two parts of linked list. So how can we do it? We have to make another function. Let's name it partition. And in this partition function, what I told you, we will pass start, we will pass end, and we will pass this list. As simple as that. And now see, if our start is greater than end, in that case that is void, so we will return null. That is not possible. Okay, what if our start is equal to end? If both are same, that means a single case. In that case, what you will return? You will return the list start. That means if there is a single linked list, that is, if there were no other elements, that is, these were not there, only this was there, that means start is also here and it is equal to end, then you will simply return this list. That is 1 4 5 will be your returning list, and you will return this head. Yes or no? So in that case, you will return the first element. This is a vector given to you, not linked list. Several linked lists are combined into a vector and it is given to you as input. Now when we are done with this, now we will start our code. That is, int mid is equal to start plus end minus start by 2. Why we take mid at this? Watch my other videos. As I told you, it avoid buffer overflow. And when we are done with this, what we have to do? We will make list node L1, we will make list node L2. And what will be these list nodes value? Because we are only merging two nodes at a time, so we will pass the partition to it. What are partitions? Partition will be start up to mid, and we will pass the list as it is. And in L2, partition will be mid plus 1 till end, and we will pass the lists as it is. And when we are done with this, when we have reached the lower case of the partition, we will pass it to merge function. and the merge function will merge it. So we will return what? Merge to list, return merge to list L1 comma L2. So that you will return. Now let's complete this main function. Inside this we will check if list dot size is 0. That is, if no list is provided to us, we will return null. If this is not the case, we can simply do return partition. Start value will be 0, ending value will be list dot size -1, and you will pass the list as it is. This is your start and this is your end. Okay, that is start is 0, end is n-1. What is n? N is the size of the list. That is all you had to do in this question. You just need to know about merge sort. You should have a basic idea about that. Or you can do it in a brute force method, that you convert this list into a array and then sort, but that will never be optimal and interviewer will ask you to optimize it. So this is an optimal approach. I hope you liked it. Let's just submit it. So yeah, it is working. I hope this video is helpful for you and you understood about recursion, leap of faith. I hope time complexity and space complexity is also clear. If you have any doubt, do let me know in the comment section. Thank you so much for watching. Please like, share and subscribe. Bye bye.